So, in this whole process, there is one question that still remains. Um, is AI regurgitating from memory, or is there an underlying reasoning paradigm that it has developed? Um, when you ask, let's go to the XOR problem. Today, I'm sure it is able to solve the XOR problem largely, or even more complex problems. Is it based on a reasoning framework, or is it just simply that it has seen something, either the same thing or something very similar, and has learned to remember it?
The whole premise of all this inductive learning setting, right? The learning from examples that we are doing is that there is some kind of an underlying regularity in the data, so that from the examples that I see, I'm able to say something meaningful about the instances I have not seen. So that is the basic premise, right? So when uh, when you're asking ChatGPT questions about stuff which has not been explicitly trained on, right, it's still giving you an answer because of the generalization it is doing. It is not regurgitating what it has learned. It is actually generalizing, right? Now, generalization is different from reasoning. Generalization basically says that okay, A looks like, it's more like analogy, right? So A is like B, that so A is to B, therefore C is to D, and that's a kind of thing. It's not quite reasoning. It's just you can think of it roughly. If you want to put it in the reasoning setting, you can roughly think of it as analogy, but it's not that. It is literally interpolation. So I have points, I have drawn a curve around the points. If I now query a point that is between the two data points that I gave you, I'll just go hit the curve, and whatever the curve tells me is the output, right? That's basically what these models are doing, right? On the other hand, classically, AI has developed a whole very rich framework for knowledge representation and reasoning, right? So people have talked about how to represent first order logic formulae, and how do you reason with these and things like that. Yeah, and ontologies and knowledge graphs and things like that. So a bunch of different things that people have come up with ways of representing knowledge and how to reason with that, right? The challenge for all of these is most of our knowledge representation framework are discrete, right? So that means that they very quickly explode in the number of things that you have to learn, then the kind of inference you have to do with it. So people have been having difficulty scaling it to very very large systems, knowledge systems, right? And there has been so people have worked on it. There's been a lot of success in it, and so on and so forth. So we have AI tools that are capable of doing this kind of reasoning, right? The marriage is still waiting to happen between this kind of inductive learners that learn these generalization and the way to push things around, right? And reasoning engines, right, which use explicit discrete representations and symbol and so on and so forth, right? So that's why people start, of course, as soon as this, of course, it's not new, right? People realize this, so they started talking about something called neuro-symbolic AI, right? So where you have the neural network for doing the representation learning and the generalization, and then you have the symbolic thing for doing the that is the ideal. But most neurosymbolic AI doesn't really get there, right? So it just takes some superficial aspects of symbolic reasoning and try to combine it with the representation learning.
So, if you start asking AI engine a whole series of why questions, like a 5-year-old would ask, why are there no pink horses in the world? And then the answer, based on the answer, go down. That would be the litmus test of whether the reasoning is more or less watertight, wouldn't you think?
No, because it's possible that whatever chain of questions you have asked, something similar was there on the internet that it actually ingested. So that is why it's so difficult to test these models. You really have to come up with some things which have not been added. So this is why the most of the benchmarks that are there in the world today, I'm not talking about any one thing. Most of the benchmarks in the world today are tainted, because there is a very high probability that that data that you used to construct the benchmark has somehow found its way into training these models at some point.